Happy Friday. So today we are going to be talking about magnets. So we use magnets in a bunch of different applications, and almost all the systems that we build, we put magnets in there. And we're going to go through those different magnets today and which magnets we use the most. We're going to start with the magnet we use the most, which is the magnetic head pulley. So on a conveyor, forgive my awesome drawings, material falls down onto the conveyor and climbs up the conveyor. And the magnetic head pulley is just a pulley. Instead of a regular pulley, there's magnets inside this pulley all the way around the magnet. The whole thing is magnetic inside. And as the material climbs up, and we're gonna use a different color, say this is steel, as the material climbs up, it's attracted to this, and then it comes down below and it falls. And we normally put a little tray here. And then the non-ferrous, we'll use blue. The non-ferrous, actually I should have used different colors for that, but the good stuff will continue down, right? It will just drop down the front of the pulley. So this is what we use in almost everything. We'll normally have a granulator next or a next machine we're putting, and as the material is falling down onto the conveyor and going up the conveyor, it will stick to this pulley and the steel will fall here and the non-ferrous will fall here. So now, the next one is the crossbelt magnet, and normally we'll have the crossbelt magnet somewhere around here on a conveyor. Sometimes we use them together, but we're gonna go ahead and draw that next. So the crossbelt magnet, so now we'll do a top view to start. So top view, this is a conveyor picture that same conveyor we had before, right? Everything is going this direction up the conveyor, and the crossbelt magnet, also called an overband, it sits above this, right? You can hang it from the ceiling. Ours has brackets that attach to the side of it. So your crossbelt will stand like this. So as material is going this way, it will jump up to the magnet, and this magnet is also a belt. So it's like a mini conveyor belt with a magnet built in the middle of it. So this middle section is magnetic. Material goes up the conveyor, jumps up to the magnet, and you can have it going either direction, but your steel will jump up and then get brushed off by the cleats on the belt. So we will do this on a view from down here looking down, right? We'll make this conveyor flat and we'll look at it this way. I think this gives you a good idea of what's actually happening. So you're at the bottom of the conveyor looking up at it, and this is your overband or your crossbelt magnet. You have two pulleys here, and then the middle part is the box with the magnet in it. As material is going this way, the steel will jump up to the magnet. And if we have our arrows or if it is going in this direction here, your steel will want to go this way and eventually fall off. And the ones we use actually have it's called a carryover magnet. So there's a less strong magnet here. This big magnet is to get the material to jump up to it. And then this one here just helps carry the material out of the way. And normally when we do this whole section, the section of conveyor that is in the vicinity of this, is made out of stainless steel. Why do we do that? We do that because we don't want this conveyor to get magnetized. If there's such strong magnet close to steel, all of a sudden your material will be tempted to go up, but also will be tempted to stay down because you have two fighting forces. So this regular steel could get magnetized. So by using stainless steel, we don't have that issue. So now the material jumps up to the magnet, comes over out of the way, and then falls down. And then all of your good stuff keeps going up the conveyor. Now what happens here is if you have a piece of steel or a piece of good stuff here, or a piece of steel that's under, and it jumps up, if it has material with it, just flip over and the non-ferrous would fall back down. So you'll see that oftentimes you'll see material that kind of climbs up, but then once the steel gets grabbed, once the steel jumps, the non-ferrous falls back down, and then you don't get this, you get a very good fraction of ferrous here and non-ferrous on the conveyor. So I could do another angle, but I think you got the point. So the next one we're going to talk about is the magnetic drum. So the drum works like this. You have a drum that is spinning, and this here has some short cleats on it. Normally they're not very big. In some of the bigger magnets, you'll have like these angles that are like this, but that doesn't really matter. And inside the magnet, you will have this piece that's magnetic inside. I'm going to draw it like this here. And this here is your magnet. So what happens is this. You will have either a vibrating conveyor, and this happens, it's either a vibrating conveyor or it can just be a conveyor. As your material is bouncing down this here, all of a sudden it sees this magnet and it jumps up to it. It wants to get stuck to this part here, this magnetic part here. The magnetic part is not spinning, it's staying fixed. What's spinning is the part on the outside of the drum. So the outside drum is spinning and it grabs your material and it scrapes it and brings it all the way up to the top. And once it reaches this point here, it just free drops it. So you end up with a bin here for your steel or another conveyor to bring it to the next spot. And then here you end up with your good non-ferrous material will fall down here. So that's how the drum magnet works. And this there's so many configurations for this. So you can have material come up underneath it. You can also have material fall onto the face of it. And if you have material fall onto the face of it, it will be different like this. The magnet inside, and these spin, so they're adjustable, so you can adjust it based on the there's a inner bearing. So there's two sets of bearings. So what you'll do here is use the green one. Your magnet would be like this. This would be your permanent magnet inside. It can be rare earth, whatever. Your material comes up here, falls on the face of this, and as everything's falling down, your good stuff continues, and then your bad stuff goes down and falls down. I see your bad, your ferrous falls into the bin here. The reason I like using the first method first, where it's down bottom and it has to jump up to it, is because as the material, right now you have a chance of, and we're gonna redraw this here because it's getting messy. You have a chance in your drum, on the surface of your drum, if you have a good piece, piece that's steel, right? That's on the surface like this. And copper, for example. You have good copper here, and then you have a big chunk of plate of steel that lands on it funny, like this. Once it reaches the bottom here, you're gonna end up with that good piece of material and the steel plate or whatever it is still holding onto that piece of copper as it goes past that point of that point here. And once it reaches out, you're gonna end up with that piece of copper and that piece of steel are both gonna fall into this bin. Now, if you do it the other way around, the piece of steel has to jump up to the magnet. So as it's jumping up to the magnet, if there's anything on it, a piece of copper, that piece of copper is generally gonna fall off. It's not gonna jump up also. So as it's flipping up, so that's why I like using, and the same concept happens with the magnetic head pulley. So the magnetic head pulley that we had originally, the very first one that I showed you, the very same thing can happen to that, which is why when we use a crossbelt magnet, material can jump up to that crossbelt first, the heavier, bigger pieces can jump up to that, and then that magnet at the end, hopefully there's not much at that point, and that's only grabbing the very small particles, and you have less of a chance of entrapment. So the biggest thing when you're dealing with magnets is you don't want your ferrous, your magnetic material, to entrap your non-ferrous. So a lot of guys do multiple sets of magnets. Sometimes they'll take all of their steel and they'll put their steel on another magnet. Even though it's all steel, they know that there's some non-ferrous in there and they want to get that non-ferrous liberated. Now, what happens if your ferrous has some non-ferrous in it, right? For example, if you took steel BX and shredded steel BX and you had a piece of steel BX that still had some copper stuck inside, well, then if you had your material and it goes on to the next one, it's stuck. There's nothing you can do for that unless you shred it further. So in our meatball lines and in our larger systems, we do that. We'll take all of our steel, and from there we'll take the steel and go into another mill, just the steel, go into another mill in case there's some entrapment, which happens quite a bit. Anyways, I hope this was helpful talking about magnets. If you have any questions, reach out. I'm always available. That's what I'm here for. So happy Friday. Looking forward to talking to you.